So today we'll look into what happens to a projectile like a football that is thrown by somebody, okay, and we want to know, what is the path that it takes. We also want to know how far it goes and how high it goes. Okay, we want to know what is its time of flight. So we will use a couple of different methods. So we will just use equations of motion and we'll use calculus to understand uh, these problems a little bit better. So let's do this. So initially the projectile is launched, okay, at an angle theta to the horizontal, okay, with a velocity equals v0, okay, with a velocity equal to v0. So now we can write this velocity, the initial velocity, in vector form, okay, like this. So the x coordinate is v0 cosine theta and the y coordinate is v0 sine theta, okay, and that tells us what the vectorial representation is, okay. This is the x coordinate of the velocity and this is the y coordinate of the velocity. Similarly, the acceleration here, okay, is 0 in the x direction. So along this horizontal direction there is no acceleration at all, and in the vertical direction it's going to be minus g, where g is the acceleration due to gravity. So we want to know, let's see how long it takes for us to uh, for the projectile to fly from this point to that point. Okay? So what we'll do is that we will assume that this is symmetric, okay, and about this about the half location we'll assume that there is symmetry. So whatever it takes for the projectile to go this distance will be the same as the time taken to go this distance. Okay, so that is the assumption, and that will prove to be correct. So now, so at the top, okay, at the top, okay, the vertical velocity is 0. Okay, because the ball keeps going up and up and up, and it doesn't go up any longer here, and then it starts going down. Okay, so the vertical velocity is positive here and it's negative that side. Okay, so if we write the vertical velocity v, right, it's equal to the initial vertical velocity v0 sine theta, okay, minus g t to get to the top. Okay, so that's, and at the very top we know that this vertical velocity is 0. Okay, so we get t to get to the top equals v0 sine theta divided by g. Okay, so therefore the total time it takes, okay, so the total time it takes, okay, equals twice the time it takes to get to the top. Okay, twice the time it takes to get from here to here. Okay, so that equal to 2 v0 sine theta divided by g. Okay, and now we know that the velocity in the horizontal direction never changes because there is no acceleration along this direction. So therefore the velocity along the horizontal direction is v0 cosine of theta, and if we multiply that by the total time taken, that will give us the range. So times 2 v0 sine theta divided by g, and that gives us the range. So we can rewrite this range as v0 square sine 2 theta divided by g. Okay, so now we found the total time of flight, we found the range, and now we want to find the total height h. Okay, so as mentioned earlier, okay, so at the top the vertical velocity is 0, equal to 0, and we'll use this equations: v square equals v0 sine theta square minus 2g h equals 0. Okay, so this comes from the equation v square equals u square plus 2 times a times the distance. Okay, so here the distance traveled is h. The initial velocity in the vertical direction is v0 sine theta. The acceleration is minus g. Okay, so here we see from here is that h equals v0 square sine square theta divided by 2g. Okay, so the interesting thing is that we found the range, we found the total time of flight, and we found the maximum height to which the projectile travels. Okay, so let's you know compute the trajectory of this. Okay, let's compute the trajectory of this. Okay, and then we'll try to find these same values from that trajectory using calculus. Okay, so let's okay, so the distance traveled along x, okay, along x equals v0, okay, cosine theta times t. Okay, and we can call that the x coordinate of the projectile. Okay, and we can rearrange this to write t in terms of x. Okay? So that's what we get. Okay. Now the distance traveled in the same time along y, okay, can be written as, okay, y equals, okay, the initial velocity v0 sine theta times t minus half gt square. Okay, so essentially we follow this equation, s equals ut plus half at square. Okay, so here a is nothing but negative g, u is v0 sine theta. So okay, so now that we've got the y coordinate, okay, at time t, so we can plug in the value of t in terms of x to find an equation, okay, that is that expresses y in terms of x. Okay, so y here can be written here as v0 sine theta x divided by v0 cosine theta, right, minus g divided by 2 x square divided by v0 square cosine square theta. Okay, so what happens here is that we can take a look. The v0s cancel out here. Okay, so that's the important thing. Now we get here tan theta times x, okay, minus g divided by 2 v0 square cosine square theta times x squared, right? So, and this is the equation of a parabola. It's a quadratic in x, so it's an equation of a parabola for sure. Now what we do here is we want to find the slope. Okay, we want to find the slope here. Okay, so now the slope is nothing but okay, dy over dx equals tan theta minus g divided by v0 square cosine square theta times x. Okay, so so there's a 2x and there's a 2 here which I wanted to mention, and these cancel out. Okay, so essentially, so what we have here equals tan theta minus gx divided by v0 square cosine square theta. Right. So now what happens here is that the at the very top the slope is 0. The slope here is 0. Okay. So dy by dx equals 0 at the top. Okay. So therefore tan theta equals gx divided by v0 square cosine square theta. Okay. So here x at the top, okay, is essentially v tan theta times v0 square cosine square theta divided by g, right? So this comes out to be v0 square sine theta cosine theta divided by g. So the r here, okay, the range, okay, is 2 times the x coordinate at the top. So it's 2 v0 square sine theta cosine theta divided by g equals v0 square sine 2 theta divided by g. Okay, so that's what we get from calculus. Okay, so now so we will derive this expression in another way. So you will see that. Okay, so let's find the y at top. Okay, the y at top equals the height h, right, equals tan theta times x at top, right, okay, minus g divided by 2 v0 square cosine square theta times x at top square. Okay, so we work through the math and we say tan theta, okay, times v0 square sine theta cosine theta divided by g, right, okay, minus g by 2 v0 square cosine square theta, okay, times v0 square times v0 square sine square theta cosine square theta divided by g square. Okay, so here the one of the g's will cancel out, one of the v0 squares will cancel out. Okay, one of the cos square thetas will cancel out. Okay, so here we get here essentially, so here you get V0 square sine square theta divided by G, okay, minus V0 square sine square theta divided by 2G. Okay, so we get V0 square sine square theta divided by 2G. Okay, that's the height. Okay, and if you recall correctly, that's what we got earlier. Okay, so that's what we got here. So we get the same value of height from the calculus. Okay, now the interesting thing is, let's set y equals 0. Okay, so when you set y equals 0, you will find this particular point here and that point there. Okay, so let's copy this thing over, or rather this one. Let's copy this over. Okay, so now we have, if we set this to 0, so now we set this to 0, which means that x times tan theta minus g x divided by 2v0 square cosine square theta equals 0. Okay, so essentially this means that either x is 0 or x equals tan theta times 2v0 square cosine square theta divided by g. Okay, so this equals to tan theta times 2v0 square. So rather, let me write this a little bit easier. Okay, equals sine theta divided by cosine theta times 2v0 square cosine square theta divided by g. One of the cosine thetas cancel out, so you get v0 square sine 2 theta divided by g. Okay, and that is the range, and this is exactly, okay, what we got earlier. We got earlier using assumption of symmetry and using the equations of motion, again using assumptions of symmetry. So we don't have to use a symmetry, but it helps. Okay, so now, so we want to find the angle, okay, at which this particular projectile approaches the ground. Okay, and so here, if we do dy over dx, okay, so if you look at dy over dx, okay, so here let me copy this thing over, copy. Okay, so dy over dx equals, okay, so and we set here x equals, so we set here x equals v0 square sine 2 theta divided by g is v0 square 2v0 square sine theta cosine theta divided by g. So we dy by dx at the point where the projectile hits the ground is tan theta minus 2g v0 square sine theta cosine theta divided by g, and there is already v0 square cosine square theta, okay, here. So the v0 square cancels out, the g cancels out, the cosine, so one of the cosine square thetas cancel out. Okay, so now here we get tan theta minus 2 tan theta equals negative tan theta. Okay, so here, so which means that the slope here is the same as theta, but it is opposite in sign. Okay, so this is a positive slope, but this in here there is a negative slope, which also means that, implies that this is perfectly symmetrical. So we were completely justified in making this assumption of symmetry, okay, when we set, okay, r, okay, as twice the distance, okay, from, so r was computed as twice the distance from here to the x coordinate at the top, okay, so that completely justifies that. So to recap, okay, what we have found is the total time of flight, okay, is this. Here is the range, and here is the height. Okay, we have even computed the trajectory of the projectile, and we have shown that to be a parabola. Okay, we found the point where the slope is 0. Okay, so and here that gives us the x coordinate of the top. Okay, we found that, and the range was computed as twice the x coordinate of the top. Okay, and we found the y coordinate of the top as well. Okay, and that is nothing but the maximum height reached by the projectile. Now also uh, we found that we found the range by setting y equals 0. Okay, so this happens to begin with when x is 0 and when x equal to the range. Okay, so this is another value, another way to get the value of range, and we found the slope again. Okay, and the slope again at the end is negative tan theta, and the interesting thing is that at the very beginning x equals 0, so we have slope equals tan theta. Okay, so the angle is theta. So I'm hoping that this really helps, okay, in understanding how projectile motion can be addressed, okay, and how to approach these equations uh, with more confidence. Okay, if you like this video, please press the like button and subscribe to this channel for further updates. Thank you.